everybody, it's Jenny from Norman S. Wright. Last week I did an update on the refrigerant phase outs that are happening now and coming in the future. And I want to stick to the topic of refrigerants a little longer. So let's talk about refrigerant blends and temperature glide. Let's get started. If you go back to the refrigerant basics video from last October, you remember that refrigerant numbers describe the chemical mixtures. So if you look at R410A, where the 4 is here, defines what type of refrigerant it is. So if this was a 0, it'd be a methane series. The 0 is not written, so you see this as R12 or R32. If it's a 1, it means it's an ethane series. If it's a 2, it's a propane series. If it's a 4, it's a zerotropic mixture. Zerotropic mixtures have different boiling points. So R410A and R454B are zerotropic mixtures, where the capital letters at the end describe specific mixing proportion of the different components. 5 is an azeotropic mixture, meaning that the mixtures have the same boiling points. There's also 6, 7, 11, and 12, but I won't go through all of those today. You can go back to the original basics video if you want to know about those. So let's move this up here, and let's look at R410A, R32, and R454B. R410A is 50% R32 and 50% R125. R32 is just 100% R32. And R454B is 68.9% R32 and 31.1% R1234YF. Single component refrigerants are comprised of only one type of molecule, so they have a constant evaporation and condensation temperature at any given pressure. Refrigerant blends are a combination of 2 or more single component refrigerants that are carefully formulated to strengthen or compensate for certain properties. So the 4 in R410A and R454B designate that they are mixtures with different boiling points. So let's scoot this over. So remember that the boiling point is the temperature where a liquid turns to a vapor, or the condensation point is when it goes from vapor to liquid. And the boiling point and condensation point for a substance is the same temperature. When a refrigerant is composed of multiple refrigerants, each with a different boiling point, it affects how the refrigerant behaves. Refrigerant glide refers to the temperature difference between the boiling points of the different components in a blend of refrigerants. The bubble point is the lowest temperature at which one of the components condenses or boils. This is the temperature where a single bubble will appear in the refrigerant as it starts to boil. The dew point is the highest temperature in which another component condenses or boils. Glide is the difference between the boiling points of the first and last components in the blend. It's the difference between the starting and ending temperatures of the refrigerant's phase change within a system at a constant pressure. Let's make more room again. If the expansion valve isn't adjusted for this glide, 2 things can happen. First of all, the liquid may not vaporize before reaching the compressor. This can cause inefficiency and lead to compressor damage. Secondly, the blend may completely boil partway through the evaporator. This will also lead to a loss of efficiency. Refrigerant flows into the evaporator as a liquid and leaves as a vapor, but temperature glide can result in the first part of the coil being cooler and the last part of the coil being warmer. So up here would be liquid and cooler. In the middle, it's a combination of liquid and vapor, and at the end, it's all vapor and warmest. And let me label this the evaporator. So going back to our 3 refrigerants, R32 would have no glide because it's not a blend. The other 2 would have glide. R410A has a glide of about 0.1 K, and R454B has a glide between 1 and 1.3 K. You may also see it written as Celsius and not Kelvin. Single component refrigerants can be charged in liquid or gas phase. It's also easier to reclaim or recycle single component refrigerants. because for blends, it often requires more complex processes to separate and purify the individual components of the blend. So that's an overview of refrigerant blends and refrigerant glide. Don't forget to subscribe to our YouTube channel, and thanks for watching.